what happens next. Okay. So, do you guys remember what we did in the last class? Manas, I'm hearing something interesting. But my question to you all is, you both is, do you guys remember what we learned in the last class?
I think we learned about
Exponents.
yes.
Ayush, do you remember that?
Most likely.
What is that?
Yeah.
Okay. Now, while we are waiting for the other kids to join, I want you guys to keep your videos on and solve these two problems for me real quick. 5 to the power 4 times 5 to the power 7. And I need the answer in the form of exponents. I don't want you guys to calculate and say, okay, this is equal to 3,049,000. Not like that. I want this in power. Okay, like exponents. And second one is 6 to the power 9 divided by 6 to the power 7. So we are trying to multiply exponents and divide exponents. Why I'm doing this? Because I want to check how comfortable you guys are with what we learned in the last class. And depending on that, hello Yaganya.
Hi, sir.
How are you, beta? Good?
Good, sir.
Good. So Yaganya, I thought we will not move on to the next topic. We will just touch upon the concept that we have learned in the last class and do some interesting problems. Okay? So I have given two problems right now. 5 to the power 4 into 5 to the power 7, and second problem is 6 to the power 9 divided by 6 to the power 7. I want you guys to quickly calculate this in the form of exponent and tell me what the answer would be. Manas, are you doing it?
Yeah.
How about Ayush?
Yeah.
Ayush, I would request you to keep your video on, beta, okay?
Yeah.
And you guys have 2 minutes only, okay? It should not take much time. That's my guess. Okay. Anybody being close to being done?
Yeah, I'm close to the first one done.
Okay, complete both of them. And then tell me.
Wait, so we divide,
So this is on exponents. I want you guys to think like exponent and solve it. Hey Kian. Were you facing any difficulty in joining the class, beta?
yeah.
Because this is open to all. So basically when you have the link, you click on the link, it should just let you in. It doesn't ask for any permission actually. Okay. So Kian, in the last class we did exponents, and I am pretty sure that we still have some open questions. So that's why I have given two problems to the kids to solve. One is 5 to the power 4 times 5 to the power 7. I want you guys to find it out. And 6 to the power 9 divided by 6 to the power 7. I want you guys to find it out.
Okay.
And solve it the exponent way. I don't want you guys to solve and say, okay, 5 to the 4 into 5 to the power 7 equals 3,695,245. Not like that. I want this to be explained in the exponent form only. And that will be super quick. Yes, Manas, you were close to being done.
Yeah, I got it up, but we have to divide it, right?
Yeah? This one is to be divided. Yes, Jaganya, tell me, what is your answer?
This is what I got.
Yeah, first one is 5 to the power 11. Second one is 6 to the power
2.
2. This is 9. 6 to the power 9 divided by 6 to the power 7.
145.
That's what I was saying. I don't need that answer. I need the answer to come in the exponent form. Because if you are not doing exponent form, you are doing a lengthier calculation actually.
So what do you mean by exponent?
This is exponent. This is what we learned. If I have 2 to the power 3, this is exponent form. I'm not saying this is 2 into 2 into 2, which is 8. I'm not saying this because this is a lengthy calculation. Imagine if I had 2 to the power 9, then it is 2 into 2 into 2 9 times. That will be much lengthy calculation. We don't want to do that. We are saying, okay, solve this and write in this form only. Okay? Yeah? So I'm actually saving some time for you guys. I'm saying, okay, if you get like Yaganya did, she showed me 5 to the power 11. That's exponent form. I want it to be that way only. Okay? That will be a very quick calculation compared to, yes, Yaganya. Yeah, Yaganya, go ahead.
Is it 6 power to 2?
6 to the power 2, yeah. So now, okay, let's see what Kian got. Kian, Ayush.
Yeah, I got 5 to the power of 11 for the first one and 6 to the power of 2.
Okay, for the second one. How about Ayush?
For the first one, I got 5 to the power 6, and for the second one, 6 to the power 2.
This one you got 5 to the power 6.
Yeah.
But why? 5 to the power 4 into 5 to the power 7. This is not 2, this is 7. Would that change your answer, Ayush?
Oh, that was 7. I thought that was 2. Sorry.
Yeah, that's why I was suspecting that is the reason, but just want to confirm. How about the second one, Ayush?
6 to the power 2.
Okay, that's nice. So, Manas, coming back to you. Did you get what our friends are doing? No? Okay. And Kian, Jaganya, and then Ayush, you guys must be thinking that no, this old man is going to teach the same thing again. But there is a reason for it. You will find something interesting about it. Okay. Now, Manas, I will strongly recommend you watch today's classes video with a peace of mind, okay, when there is no disturbance. You watch the video of the class and do the work. I mean, like whatever I'm doing, you will watch it, then pause it, and then you do yourself, okay? Then you'll be able to relate, okay? Now, look at what I'm doing now. So, Manas, share it, okay? Let's say if I have 2 to the power 3 into 2 to the power 4, okay? I don't want you to do 2 into 2 into 2, that is 8, and this is 2 into 2 into 2 into 2, that is 16. So 16 into 8, 128. I don't want you to do that because these are still cute exponents, okay? These are not bothering us. Imagine a situation where I play with you and I say 2 to the power 392. Imagine, whole day will be gone just finding out the value of this guy. Okay? So, what we are learning as part of exponents is this. First thing, the stepping stone of exponents is the fact that if I have 2 into 2, I can write this as 2 to the power 2. If I have 2 into 2 into 2, I can write this as 2 to the power 3. If I have 2 into 2 into 2 into 2 into 2, I have 1, 2, 3, 4, 5 2's. I can write this as 2 to the power 5. So this form of representation is called the exponent form, where this is called the base and this is called the power. Okay? Does it make sense so far? Yeah? Now, what we are learning from this is what we will relate to now. Okay? All right. So, if I say 2 to the power 2 into 2 to the power, let's pick a different number, otherwise you will think that exponent is all about number 2. That is not the case. If I say 4 to the power 3 into 4 to the power 2, what will happen? This becomes what? 4 into 4 into 4. This is by 4 to the power 3. And then I have 4 to the power 2, which is 4 into 4. Okay? Alright? Hello. So just give me 1 minute, beta, okay? Just 1 minute. Hello, beta. You are Swetcha?
Yeah,
Hello, sir. How are you?
A little bit late because we were trying to find the GPS somehow was showing in the back. I don't know
That's
why.
with the GPS. I can blame it on Google or Apple.
Yeah.
So we don't have any child in the class. You'll be the only child.
Yeah.
And this is your first class. This is her first class. I would want you also to witness what we're doing in the class.
Okay, sure.
Please be my guest.
We'll do that. Thank you.
I have kept the door open because
Thank you.
I was waiting for Swetcha.
Oh, okay.
Some kids who come in person, they did not turn up today. I have to screen grab this stuff. Okay, you can sit. Okay, so welcome to class, beta. Okay. So we have one friend for you guys. Her name is Swetcha, and that's why I took a break of a minute from you guys. Okay. Now I will do something to make Swetcha aware of what we do in the class. This class we don't memorize, okay? Because I'm an old guy, my memory doesn't support me anymore. It's all about concepts. So we'll focus on learning concepts, following it, then applying those concepts for solving problems. Okay? That's what we do. So what it means is I would need your undivided attention in the class. Focus on what we are learning, what we are trying to understand, then debate, argue with me if there's something that is not clear or clear to you. But don't assume that everybody is saying, okay, why should I ask? No. You have your own doubts to be clarified. Everybody has their own doubts. Let's not worry about it. But the notebook and the pen that you have, you will use that only for solving problems with me. Because everything that I'm doing is getting recorded through this iPad. So you will have this video of the class afterwards for your review, for doing a recap of or recollecting what we are learning in the class. Okay. So that way you're relieved from the pressure of noting down everything or forgetting anything, and you'll focus only on concepts. Alright, that was the starting point. Now, in today's class we are learning, we have learned exponents, and I'm seeing that some of the kids are still, maybe you can move a little bit to this side so that, you can move the table, be comfortable, stay as closer to the heater so that you get the warm, this thing, okay? So, we have learned the exponent concept. Some of the kids are clear, some of the kids are still trying to find it out. So we are doing it all over again. Okay? And that's what we'll do. Okay? So anything that you learn in the class, if you forget, if you are confused, ask daddy, mommy to send me a message saying, okay, Swetcha wants this concept to be explained one more time. We'll figure it out. Okay? Because if we learn something, that doesn't prohibit us from learning it again. Yeah? As long as you guys are clear about what you learned, I'm good. Okay, all the speech is over. Let's back to math. Now, exponents. What do you know about exponents?
So I can't really explain it, but I know, like, for example, if 4 has an exponent of 2, then it would be 4 times 4.
Yes, spot on. So exponents is nothing but a way of representing the number in a crisp and shorter form. Okay. So now if I'm saying 4 into 4, I don't want to waste so much of ink. I can write this as 4 to the power 2. My wastage of ink gets serious when I have to do it 20 times. Okay. I might run out of budget for ink. That is where it gives me the ability to represent in a different, shorter, easier way. Okay, that is all about exponents. But there are certain rules of exponents. That's what we are learning and practicing in the class, and we will see how comfortable that is. So now, Manas, do I have your attention as well? Manas, are you with me?
Yeah.
Okay. Now, going back to the same problem. I'm not going to use the number 2. This time I'm going to use number 7. If I have 7 to the power 3 into 7 to the power 2. When I'm trying to do it, I don't want you guys to multiply 7 to 7 to 7 and whatever you get, multiply that with 7 to 7 49. Okay? I don't want you guys to do that. The idea is to multiply this in the shortest way and represent that in the easiest way. Alright? Now, 7 to the power 3 is what? 7 into 7 into 7. I'm just breaking it down. Peeling off the new. Okay? Now, when I have 7 to the power 2, this is equal to 7 into 7. So, whatever we have broken it apart. Everything is split into simplest way. Now, when I have 5 7s written together, minus how much that would be if I have to write that in exponent form?
Wait, what?
I have 5 7s multiplied with each other one after another. What will that be?
5 sevens. Like there's 5 sevens.
7 to the power 5.
Exactly. If 7 into 7 is 7 to the power 2, 7 into 7 into 7 is 7 to the power 3. If I have 7 multiplied 5 times, that will be nothing but 7 to the power 5. Manas, does it make sense?
Yeah.
I'm calling out your name not to put you on the spot, just to make sure that I have your concurrence as well. Yep. Swechha is with me in the classroom, so I can look into her eyes to make sure that she got what I'm saying. Okay. For you guys on the screen, I have to explicitly call it out. But everybody with me so far, right? Everybody?
Yeah.
Ayush, Kian, everybody. And guys, keep your videos on, okay? So, from this, what did we see? This became 7 to the power 5. And if you observe this carefully, between this and this, what is common is the base is the same. Your exponents getting added. That is your power is getting added. That is the basic rule of, first rule of exponent, which says when you are multiplying two exponents with the same base, your power gets added. Yeah? So if somebody says a to the power 59 into a to the power 64, you will not start worrying about it. What you are observing here is your base is the same. So this is an exponent, this is also an exponent, and both the exponents have the same base. So my output will be same base and the power being added. 54 plus 59.
123.
Whatever it is. Yeah. So there are a couple of statements that I make in the class which you guys will not like much. I say I don't care about the answer. Why so? Because what is important for all of us to know is the approach part. As long as we are clear about the approach, whether it's 123, 124, you guys are smart enough to find it out. My emphasis is more on the approach part. As long as you can narrate the story of what you know. As soon as I start talking about exponents, what did I say? Exponent is another way of repainting larger numbers when you are multiplying it by itself x number of times. So, as long as the story is in your mind very clearly, you can play with it. Yeah. So I'm certainly wanting you guys to play with math. Manas, is this okay so far, or something is making you scratch your head and lose hair like me?
Scratch my head.
You are scratching your head?
Yeah.
Don't scratch. You will end up losing hair like me. Is it clear or not clear? That's my question.
Yeah.
Clear? Now, so we learned the first rule of exponent, which says any number to the power a times other exponent with the same base to the power b, this becomes a plus b. So you can replace x with any number that you like, replace a and b with any number that you like, and you can use this general formula for using it. So far it's okay? Now, second rule, Kian and Ayush, are you guys with me?
Yes.
And you guys must be thinking that this is something that I'm sure about. I know you guys are very clear about what I'm talking about. So is Jaganya. But then I will give you enough food for thought. Let's say if I'm talking about a to the power 6 divided by a to the power 4. Multiplication was easy peasy. You added the power and you were fine. When we are doing division, what happens? We play with math. So how do we play? A to the power 6. Let's first look at it in a very simple way, okay? One guarantee to you, your teacher is not intelligent. That's a problem. So I'll keep things as simple as possible, okay? I'll keep breaking it down. So Manas, as you already know, your teacher is not intelligent. So whatever we know about exponent, I'm just breaking it into simple form. I have 8 to the power 6, that means 8 into 8, 6 times. Yeah, so far it's okay? 8 to the power 4, that is 8 into 8 into 8 into 8, 4 times. So far looks okay? Nothing scary. Halloween is over. Yeah? Okay. Now it's time to play. I call it tic-tac-toe. Meaning when you are multiplying and dividing, I mean in the fraction form, right? You are doing multiplication here and multiplication here. What you can do is you can knock off the matching numbers. So I call it tic-tac-toe. 1 8 and 1 8, tic-tac-toe, done. Another 8, tic-tac-toe, done. One more 8, tic-tac-toe, done. This 8 and this 8 also tic-tac-toe, done. What we are left with?
8 times
8 into 8. What I can write this as?
60.
8 to the power 2.
Yeah.
Yeah? What are you seeing here? Both had same base, the power of the numerator and power of denominator. You subtracted the power of denominator from the power of numerator. That is how you got a 2. Minus, am I making sense? Let's look at it one more time. 5 to the power 4 divided by 5 to the power 1. Okay? What does 5 to the power 4 mean? 5 into 5 into 5 into 5. 4 times. What does 5 to the power 1 mean? Only 5. Time to do tic-tac-toe again. 1 5, 1 5 gone. What we are left with? 1 2 3 5s. What does it mean to us in exponent form?
5 to the power of 3.
Isn't that same as 5 to the power 4 minus 1?
Yeah.
That becomes the second rule of exponent. Do you guys agree? Everybody? Yaganya? Yaganya is saying, I've told you 100 times. Yes, I agree. No, I'm just kidding. Ayush, are you with me, beta?
Yeah.
Kian and Ayush. Ayush, I think he has some technical problem. Kian, keep your video on, beta, okay? Unless I make eye contact with you, I don't get confident. Okay? So this becomes the second rule, which says x to the power a divided by x to the power b equals x to the power a minus b. Yeah? So tomorrow if somebody tries to bother you with a difficult looking problem saying, okay, find out a to the power 20 divided by a to the power 15, you will say, I don't care. My second rule says, when I am dividing one exponent by another exponent with the same base, my power of denominator gets subtracted from the power of numerator. That's it. So, that is 8 to the power 20 minus 15, 5. Yep. One very stupid technique that I apply is, whenever you are writing something which looks lengthy, cumbersome, try using brackets as much as you can. If I am doing this, a to the power 20 minus 15, if I don't put that in bracket, sometimes if I am messing with my writing much, I might write it like this and my whole answer will go for a toss. So that's what I'm saying. If you're doing this, try writing it in the bracket so that way there's no space for confusion. Is that okay? So this is our second rule of exponent. X to the power a divided by x to the power b equals x to the power a minus b. Everybody with me? Did I scare Manas? He disappeared.
He keeps on getting disconnected.
Okay, he will be back. And if he doesn't come back, he will have the mammoth task of watching the video of the class to catch up on what we are doing now. Okay? Because this is the second time I am explaining this concept, that means third time he can ask, but before that I'll say first you watch the video of the class. That's the purpose of the video. Now, if I have now Kian, Ayush and Yaganya and Swechha, if I say x to, no, let me not say x to the power something. Let me say 5 to the power minus 4. What does it mean? Kian, Ayush, Yaganya, I'm giving you guys food for thought. I'm saying, so far life was looking easy. 5 to the power 2, okay, 5 into 5. Wonderful, no problem. 5 to the power 4, 4 times. I'm saying 5 to the power minus 4, what does it mean? Yep.
I think minus 5 times minus 5 times minus 5 times minus 5, like minus 5.
No, look at it differently. See, if I'm trying to do minus 5 times minus 5 times minus 5 times minus 5, I will write this as minus 5 to the power 4. I will not write like 5 to the power minus 4. Yeah. So whatever is my number getting repeated, I will be very explicit. That's, see, now I'm using the bracket again here, right? If I don't put a bracket here, I will confuse everybody. I'll get the power value of this and then put a minus to it. But I'm saying no, this is the one. Okay? So that let's misuse the brackets as much as we can, as long as it gives the clarity. Yeah? So Kian, what's cooking up? What's in dinner?
Roti and dal.
This food I'm talking about. Think, see again. I'm making you guys think, okay? I have ready-made answer for this. But when you start thinking, start pushing yourself a little bit beyond your comfort zone, that is where you will get a very nice idea. Yaganya, what's happening now? Yaganya and Ayush. I was telling you guys that no, if I'm making an easy ride, there's an interesting problem in the making. Okay. Shall I? Yaganya, Ayush, Kian, shall I? Go ahead.
I can't like see your screen. I don't know what you wrote.
Are you not going to see my screen? One more time.
I can just hear you. I can't like see you.
Okay, so then there's a magic wand. There's a magic trick for that. Disconnect and join back again. That's a very commonly known problem. When any child is not able to see the screen, just disconnect and join back. You'll be able to get this problem fixed.
I can see, but I can only see like half of it.
Okay. Can you see my finger? Oops. So, Swechha, tell me, what all is coming in your mind?
I think we would multiply -4 5 times.
So, see, my basics will not change. My basics will remain the same for our lifetime. That will not change. So, if I am saying something to the power something, that means that is getting multiplied by itself that many times. Right now, my problem is -4. What do we interpret from that? That's where I'm trying to make you guys think out of the box.
Look at x to the power of a by x to the power of b and think about it, how that minus b came there. Like x to the power of a minus b, how did we do that? So,
Never mind.
Yep. Are you guys with me now?
Yeah.
Can you see me and can you hear me okay?
Yeah, why did you leave?
I got kicked out from my own meeting.
Yay!
See? Now, so here's the thing. Any problem is simple if we think so. Any problem is difficult if we believe in that. Now let's look at it in a very simple way. As I said, I'm not an intelligent person and I have lost all my chances of becoming more intelligent. Okay, so I will use simple techniques for solving this. If I have something to the power minus 4, can I say this is 0 minus 4? Is this okay?
Yeah, you could say that.
Yeah?
Yeah.
Kian, agree? Ayush, agree? Yeah?
Pretty sure.
Now, one more time. I have 5 to the power minus 4. Can I write this as 5 to the power 0 minus 4?
Yeah, you could write that.
Yeah?
But
Uh,
yeah, the 0 minus 4 is negative 4.
I have but 2, that is 2. If I have minus 1, that means 0 minus 1. I have minus 2, that means 0 minus 2. Doesn't make a difference. I'm just representing that differently. That's all.
So it doesn't matter?
Yeah, it doesn't matter. What is minus 4? Let's think money. If I have $20, that is a positive amount I have. If I have borrowed $20, let's say from Ayush, that is not a money that I have. I have borrowed it. So my balance is minus 20. As soon as I get 20, I have to return it, right? So I had 0, I borrowed something. I borrowed 20, so I have minus 20 now. Yeah? So let's not confuse it, okay? Simple thing is, if you have a negative number, that means 0 minus 20 you can say. Because 0 doesn't make a difference. I'm just representing it differently, that's all. If I say I have $50, $50 plus 0, does it make a difference? No, right? You keep adding 0 10 times, doesn't make a difference. I have $50, or I can say I have $50 plus 0 plus 0 plus 0 plus 0 till I get tired. Yeah? Same way, I can say I have minus 4, I can say I have 0 minus 4. Same thing, right? Yes or no? Ayush?
Yeah.
Yeah? Okay, I forced you to believe that, okay? Let's believe it for now. Now look at, okay, now let's recall what we learned just now. 5 to the power 4, let's say 8 to the power 4. I'm just changing this. 8 to the power 4 divided by 8 to the power 1. What does it become?
8 to the power 3.
8 to the power 4 minus 1. Let's go slow so that way we can relate to it. Now, can I rewrite that a little differently? Can I say 8 to the power 4 minus 1 equals 8 to the power 4 by 8 to the power 1? I just reverse it, flipped it, that's all. Now look at this equation. I have 5 to the power 0 minus 4. When I have something power something minus something, the first thing is my power of the numerator, second thing is the power of my denominator. Yeah? Now I have 5 power 0 minus 4. That becomes 5 to the power 0 by 5 to the power 4 by relating to this equation.
I can't see half of your board.
You can see half of my board. How about now?
Yeah, now it's okay.
So let me repeat myself, okay? So we learned two rules of exponents. Something to the power a times something to the power, same thing to the power b becomes something to the power a plus b. When I am dividing one exponent by another exponent, my power of the numerator minus power of the denominator becomes my output. So we are relating that to the real example, x, y, z, these are, okay, fancy looking thing variables. Let's look at something that we can relate to. So I have, let's say, if I have a to the power 4 divided by a to the power 1, if I use this formula or the rule that we have learned just now, it becomes a to the power 4 minus 1. Now rewriting this in a reverse order. If this equal to this, that means this equal to this. Yeah? Why am I rewriting that? So that I can relate it to with this value. So if I have something minus some base to the power something minus something, that becomes this to the power this as a numerator divided by this to the power this as a denominator. Now if you look at this becomes 5 to the power 0, this is my numerator, first one is my numerator and this one my denominator. 5 to the power 0 is how much?
1.
1. Yeah, it's 1. Any number to the power 0 is 1. If I promise you tomorrow that I'll give you $1 billion to the power 0. I'm promising you only 1. Any number to the power 0 is 1. Yeah, except 0. 0 to the power 0 will remain 0. Okay? But any other number, be it 0.001 or be it 1 trillion, to the power 0 will give you a 1. Okay? Yeah? So Ayush and Kian are laughing at me because I said if I promise I'll give you
Hey,
one.
he laughed. I didn't laugh.
It's okay.
I laughed because he taught me what I was doing with the emojis.
Oh yeah.
Hey, I only said thumbs up.
Calm down guys, calm down, it's okay. We will have more fun with math than anything else, okay? So here, the message is very clear that any number to the power 0 is 1. So here when I have 5 to the power 0, this becomes this becomes 1 by 5 to the power 4. See what happened? You had a number to the power, negative power, that became 1 over same number with a positive power. If I say 3 power minus 2, you can simply say this guy will move down and sign will change to positive. If you move something from below to above, same thing will happen. The power changes from positive to negative, negative to positive. Yaganya, can you hear me and see me okay now? Yaganya, you have joined. Are you Yaganya? I was asking Yaganya, she joined back and she was facing some problem, that's why I'm asking her, okay? You guys are getting tempted to talk. I am not asking you guys not to talk, but let's make sure that we are talking for a reason. Yeah, you saying something, Beta?
I have a question though. Above there, is that a -2?
It's a negative 2. 3 to the power negative 2. So it will become 1 over a positive power of the same thing. Like we saw here, right? This to the power minus 4 becomes this to the power 0 minus 4. We can write it that way. And that becomes, by relating to this thing that we saw, this to the power 0 divided by this to the power 4. So we saw this movement actually. It's more of a movement. It's more of a, like when you move some number from one side of equal to the other side, negative becomes positive, positive becomes negative. Same way here, when you're moving across the negative power to other side of equal to.
Oh, I get it.
Yeah. If you have something like, let's say here, 3 to the power 7, you can also say this will be same as. When you move it across that equal to sign, the power of the exponent reverses from positive to sign negative and vice versa. Is everybody clear or it's only me convincing myself? Kian, Ayush, Yaganya. I see this expression Ayush. Does it mean you're not clear?
I was thinking what emoji to put.
A lot of energy is going for emojis. Okay, come back to the class. So this part is clear. Now, Swechha got a shocker of the day. In the first class, I'm telling her to believe that something to the power 0 is always 1. But why?
Because like there's only like 1 5.
Okay. Yaganya, can you hear me and see the board okay? This time? Kian, do you remember how do we find out a number to the power 0 is 1?
No.
No? Okay. I'll tell you guys a very interesting story. I mean, I claim to be knowing math enough so that I can dare to teach kids. Okay, that's what I'm doing right now. So, in one of the class, probably 6-7 months ago, I was trying to teach kids, saying, okay, this is exponent and all that, and then I said, okay, something power 0 is 1. And very innocent and apt question that I came across, but why? And trust me, I'll be shameless in acknowledging that I had no answer for that. I always knew from my childhood that okay, any number to the power 0 is 1. But why? That why is a very important element of any and every learning we do. When I heard that question, that made me feel bad. But okay, I don't know. I never bothered about it because my teacher said so. And then I was doing, puja one day. I just kind of, pray every day for 2 minutes. And I was thinking, what was that question? It was bugging me actually. Then I recalled, oh man, I had the answer for it. I never just bothered about it. Now look at it. If I say 10 to the power 0 equal to 1, don't believe your teacher, ask question why. That is how the teachers also learn. Now look at it, 10 power 0. Can I say 10 to the power 0 as 10 to the power 2 minus 2? Is this okay? 2 minus 2 is 0. I can say 3 minus 3 also is 0. 7 minus 7 is also 0. Go back to this guy. If you have something to power this minus this, that means 10 to the power 2 divided by 10 to the power 2. Numerator here, denominator here. If you have this, something to power 2, you can write this as, something to power 0, you can write this as 2 minus 2 or 1 minus 1 or 5 minus 5, whatever you like. Now 10 to the power 2 divided by 10 to the power 2, that is 10 into 10 by 10 into 10. What is that you will get out of it?
1.
That's the answer. That's the reason for any number to the power 0 as well. Okay? Kian, did I make sense or I was blabbering? Kian is thinking. What is that?
Not really.
Not really. One more time. Good things are to be done over and over again. This time I will pick a different number and see how trustworthy is this calculation. If I have 20 to the power 0 and I am forcing you guys to believe that that is 1, right? And you guys are asking me why. I am saying okay, 20 to the power 0. Can I write 20 to the power 0 as 20 to the power 3 minus 3? Is this okay? Because 3 minus 3 will give me a 0 only. Yeah? Now, look at this and look at this. When you had something to the power something minus something, that became something to the power something as a numerator and something to the power something as a denominator. From the second rule of exponent, by flipping it. So here, you have a situation, you have something to the power something minus something. So this will become your numerator of the exponent and this will be your denominator of the exponent. So it will become 20 to the power 3 divided by 20 to the power 3. Yeah? So far okay? Kian, Ayush, Swecha?
Yeah.
Make sense?
Yeah.
Easy concept? Now if I have 20 to the power 3, that is nothing but, let's look at very simple way. You'll say this same thing by same thing is 1. I understand. But no harm in being even simpler. And let's say 20, I'm writing 20 into 1. Tic-tac-toe, tic-tac-toe, tic-tac-toe. What am I left with? 1.
1.
So 20 to the power 0 also became 1. We saw 5 to the power also 0 also 1. If you want to play with it, put 1 million to the power 0 and see how much it is. Yeah? Kian? Ayush? Am I making sense or not?
Yeah.
If I'm not, I can do it one more time. Yeah, I'm enjoying it. Are you okay with that?
Yeah.
Clear? So, what does it mean to us? See, exponents rule. We are not trying to memorize anything as part of the exponent rule. Jaganya, are you back? Jaganya, are you able to hear me okay beta this time? No? Technology is not friendly always. Okay. So, as part of exponents, if you guys wrap your head around this, the idea is not to memorize formulas or learn or kind of put your heart and soul for mugging it up. The idea is to relate these concepts. This formula that we are seeing here is not something that was given to us, say, okay, if you memorize it, you'll be fine. This formula is something that we ourselves derived. We saw it, okay, 2 to the power 2 is 2 into 2. if I'm doing 2 to the power 2 into 2 to the power 3, I see 5 2's coming together. So we interpreted that and became a formula for us. Whether we remember this formula or not, completely up to us. But what we need to be clear about is the underlying concept. As long as that is clear, we'll have a smooth sailing. Yeah? So we saw this rule and this rule. Is Kian, Ayush, Swechha clear about it?
Yeah.
100%?
Yeah.
And you guys will see a glow in my eyes when I'm doing math. Why? Because this has stayed with me, this math has stayed with me all this far. Okay? I want you guys to feel about the math same way. Okay? Because I mean, if you like the subject, if you enjoy the concepts, every day when you grab some new concept and then you practice it, it'll become a cakewalk. That is my end goal. I'm not here to make sure that everybody gets 100%. No, I'm not very interested in that. I want you guys to learn and enjoy every concept that we learn in the class. Okay? In the simplest possible way, where you can make a story out of it. Once you go home, if somebody says, okay, what did you learn? If you're able to give a speech for 15 minutes, okay, we learned about exponents. It's a very important, interesting concept. Let me explain you what. If you're able to get to that stage, you will have no other choice but to like this subject. Okay? All of you. And then everybody's eyes will glow as much as it's glowing for me. Okay? Alright, let's look at the next rule of exponent. Okay? And that, to keep looking at this guy just to make sure that the recording has not stopped. The third rule is, I'll not tell you the rule. If I say 2 has become a favorite number for me today. Okay, let's look at 7. 7 to the power 2 to the power 4. How much that will be? And think simple. Because simple things are nice. Think simple, yeah.
49 to the power 4.
You're going in the right direction, but help me interpret this as a rule. Yaganya, are you back with a bang?
My laptop kept shutting down for some reason.
Time to buy a new one, beta. I'm just kidding. I'm not trying to put extra stress on parents. Okay, but can you hear me okay now? So whatever we did, you can catch up on that by watching the video of the class that you missed. Okay, I'm not going back to that one, but I'm going to the third rule of exponent, which is something to the power 2 in parentheses to the power 4. How much that would be? I got one answer, and you're not wrong with that. I'm just wanting you to think a little differently. Kian, Yaganya, and Ayush, are you guys following what I'm asking?
Yeah.
Then you guys owe me a response. Tell me what it would be.
I got 49 to the power of 4.
I'm not saying you're wrong. I need another answer, which I can convert into a rule. Then I'll claim that this is the rule I have derived. Yep.
Would 7 to the power 6 work?
Oh, you're right.
So see, look at my hands. It really gets dirty by the time class gets over. I want you guys to get your hands dirty as well in the class. Do it on a notebook and you will get some clue. And again, I'm just giving you guys some clue, okay? Jaganya, what's happening, beta?
I'm trying to.
Okay, I'll give you guys 2 minutes. We have exactly 10 minutes left for the class. So I'll give you guys 2 minutes and then I'll use the remaining 8 minutes for my speech. Okay. Are you guys close to being ready for giving me some different answer? Yes, Aganya.
Sorry, I got 7 to the power of 8.
Okay. Why are you telling me that as an answer with a low voice? You have to shout back at me. Say, sir, I got 7 to the power 8. See, that has to reflect in how you guys respond to the questions, okay? That gives me more confidence. You are absolutely right. What about you, Beta?
I didn't really get it.
Okay, don't worry. So this is
7 to the power 8.
7 to the power 8. So here's the thing, okay? I always say, keep it simple. You will find some magic in this. If I have something to the power 4, something in parentheses to the power 4, what does it mean? 7 to the power 2 into 7 to the power 2 into 7 to the power 2 into 7 to the power 2. Isn't it? Whatever I had in the parentheses to the power 4, meaning that thing is getting multiplied with itself that many times. Now look at this. These two together will become what? 7 to the power 2 plus 2, 4. And you have these two. It becomes 7 to the power 2 plus 2, 4. Applying the first rule. Yeah. Now you have again same two base. Same two exponents with the same base. 4 plus 4, 8. Yeah? Or look at it differently. This, what is happening? So, there are two things that we are deriving out of it. One is, when you are multiplying exponents with the same base, essentially what you are doing is adding them all together. So this rule doesn't apply only when you are multiplying two exponents. If you are multiplying 5 exponents with the same base, you can just add all the powers together. So here, what are you doing? You are doing repeated addition of the power, which is multiplication. So you will simply say, if I have x to the power a in parentheses to the power b, this will be x to the power a times b, because I am doing repeated addition. Does it make sense? Everybody?
Yeah.
Yeah? So again, after coming to US, okay, it was way back in 2004 when I came to US. I was told by one of my friends that if you are doing something and it's not working, you're putting a lot of effort, it's not working, that means you are not doing it right. So here in the US, basically most of things are easy to do, right? In India, I've seen people putting a lot of hard work, a lot of effort you have to put for doing certain household chores like we do. Here everything is designed in such a way that you don't have to put effort. Same thing applies in math also. If you're doing something and you're putting a lot of effort and you're not getting it, that means you probably took a difficult route. Take a step back and then try it again, it will be easy. So here, keep things simple and easy, it will be fun. Now, we have 6 minutes and I literally want to waste those 6 minutes for Swechha. Now, Swechha will say, what kind of teacher is this who is wasting time? Right? So, I'm telling you guys and I'm reminding Ayush, Kian, Yaganya and all the kids who will watch the video who have missed the class today. There's a very basic concept or a approach that I have derived for you guys that I call as RAN. Now, Aryan ran, somebody ran. The story behind this is who wins the race depends on who ran the best. Yeah? Is that a good story? Who wins the race depends on who ran the best. Now let's decode what is ran here. R stands for read. Read, read, read and read. If you have a question to solve, read the question a couple of times. You will see that the question becomes half difficult. Then A stands for analyze. You have a problem to solve. You read the question a couple of times and you are doubly sure, triply sure that okay, you are very clear about what the question is asking for. And you have all the information that you have got from the question. Then you are putting your thoughts together. Okay, this is the information, this is what it is asking, these are the details that I have. I can probably use this approach. You are making a blueprint. You are not dare to solve the problem. You are just making a plan. Then comes N. This N stands for Nike. What does Nike say? Just do it. So you have heard the punchline, the slogan of Nike, so just do it. So here, in summary, what I'm conveying to you all is, when you have a problem to solve, make sure that you are putting that effort to read the question a couple of times. Don't move forward without being sure about what exactly the question is asking for. It's okay to spend time to read the question a couple of times, then getting a wrong answer. Make that investment in the beginning. Then you put your thoughts together. It might sound like, okay, this teacher is asking to spend 2 minutes extra for every problem. I'm not talking about wasting 2 minutes here. It's not 2 minutes. Actually, when you start practicing that, it's a matter of probably initial 30-35 seconds. But then and then you jump on to do it. Meaning, read the question, analyze, come up with your plan, then you start doing it. In a way, what will happen is, if you took the wrong approach and you wasted 10 minutes and then you realize, oh, I should have done it differently. That 10 minutes wasted that you can avoid by following this approach will help you save those precious moments during the exam. Yeah. It's okay to attempt 10 questions and get 9 of them right, then attempting 20 questions and getting 15 of them wrong. Yeah. And I'm certainly not shooting for this. I want you guys to get 100%. But let's not stress out with the number 100%. What I'm saying is, whatever you're doing, if you try doing it right, you're improving your chances of getting better at what you're doing. Was that a good speech, everybody? Yeah? Kian, tired of me?
No.
You heard it 3rd time probably. And it's okay to hear it a couple of times, because I'm trying to inject this idea in your brain that, guys, if you get a question, don't get tempted to solve it immediately. Put your thoughts together, come up with your plan and then do it. And if you start practicing it, this whole exercise of these first 2 steps will only take probably 20-30 seconds, depending on how verbose the question is. Most of the questions will not take more than 30 seconds. But it will save you those precious 10, 15, 20 minutes, and it will boost your confidence with respect to how you are approaching things. Okay, let's make it a habit. I'm sure it will do magic for us. All good? Yeah? Then, if all good, then why are you guys wasting time with me? Have a good night. Take some rest. We'll talk again day after tomorrow. Alright? Bye, 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 bye.